In this video, we're going to be learning about polynomials. Now, surprisingly, you guys have learned about polynomials before, or at least thought of polynomials or used them in your life, whether in math class or out of math class. I want you to think about that, and at the end of this video, reflect on where you may have used polynomials. So let's start off. What is a polynomial? But to get there, we first must look at a few parts of a polynomial or restrictions to polynomials, or might say boundaries. So first of all, a polynomial has terms. Okay? There must be at least one term. Now if I look at this here, this is a polynomial with 3 terms because I have right here 3 different numbers and they're separated by addition signs or subtraction signs. If we notice here, we have 4 multiplied by x squared, but yet this is all considered one term. So multiplication and division do not separate terms or give us new terms. The only thing that gives us new terms is adding and subtracting. Now another key thing that we have to look at here is these 3 terms are different in some key ways. I look at this 5. There's no variable by this 5. These 2 terms have an x, but look at the exponents of these x. The exponents are not the same. Therefore, we cannot combine these. I cannot subtract them. Therefore, they are different terms. Okay? So there are 3 terms where we have different properties. And we'll get to those properties later. So, what else do we know here? Well, exponents of the exponents of every term must be a whole number. We cannot have any fractional exponents or negative exponents. So if I look at this here, this first term is 5x squared. So my exponent is a 2. Here it is 8x, and there's an imaginary 1 there. Here we have 9 and an imaginary 1. So these are all whole number exponents. Another example would be right here, 5x to the 7. This would be a polynomial of only one term. We have a power of 7. That is a whole number. So another key thing is exponents must be whole numbers. So what can exponents not be? We cannot have negative exponents and we cannot be dividing by variables. So no term can have a negative exponent and no term can be dividing by variables. And another thing, remember, we said exponents must be whole numbers. So this is another no-no. If I have 7x and I square root it, this here is going to be another no. Or this is the same thing as saying something like this, 7x to the 1 over 2. Here we have a fractional exponent. So once again, this is a no. Remember, they must be whole numbers, the exponents, and we cannot divide by variables. So now we're going to look at what types of polynomials we have. There are 3 specific types of polynomials that you guys must know. The first one is a monomial. Mono meaning 1. So we have one term. So here we have a 5, which is an example of one monomial, and here I have a 6x squared as an example as another monomial. A polynomial can also be a binomial. Okay? So here it has 2 terms. A binomial means it has exactly 2 terms, no more, no less. So here I have 2 terms, 2 plus 4x. Here I have 7x squared plus 3. And then our last specific type of polynomial is called a trinomial. In a trinomial, it has 3 terms. Think of a tricycle. Binomial, 2 terms, like a bicycle, tricycle, or triangle. 3 angles, tricycle, 3 wheels, 3 cyclical wheels. Now, a trinomial has 3 terms. So here we have 3x plus 4 minus x squared. Notice they are separated by an addition or a negative sign. Multiplication does not make new terms. So, and here, all of these have different exponents, or variables with different exponents. Now, let's go to certain definitions for polynomials. So what are the parts of polynomials? Or these you might say are parts of the terms of each polynomial. So first of all, let's look at what is a variable. Well, a variable is a letter or symbol representing an unknown. Oh. Okay. What is a coefficient? A coefficient is the number in front of the variable. Notice how I say in front, so we always organize it. So the number we're multiplying the variable by is always in front of the variable. Okay. Now, what is a degree? Now, a degree is the term with the largest exponent. So a degree is the term or the value of the term or the value of the exponent in the term with the largest exponent. Okay. The next one is a constant. A constant is the term without a variable. So, let's look at an example here. If I have 5x plus 7x squared minus 8. Well, I'm going to look at certain things here. First, let's try and find what is my variable. So my variable is a letter or symbol representing a whole number. So here my variable is x. Okay? What is my coefficient? My coefficients are the numbers in front of a variable. So I have 5 and I have 7. My degree is going to be my largest exponent of a variable. So my degree is my largest exponent of a variable. That's going to be here 2. And my constant is the term without a variable. So my constant is going to be 8. If I was to write this properly, we always want to start with the biggest degree and working down, descending to smaller. So to write this out constantly, I should write this out 7x squared plus 5x minus 8. And we say for here the degree is 2, my coefficients are 7 and 5, and my constant is 8. Another question we might get is, what is the leading coefficient? Well, my leading coefficient is going to be 7, because it is going to be the coefficient in front of the largest variable. Here's another one here. What is the coefficient of something like this? In this one here, my coefficient is going to be this imaginary 1. So if there's no number in front of a variable, we have to imagine that it is 1. So for my last question here, we're going to represent this using algebra tiles. Now, you have to be very close attention. Make sure for every test, every quiz, you follow the rules of what it says. On the PAT or whatever you write, follow the rules. If it says black is positive, then black is positive. If white's negative, then white's negative. It'll switch all the time. Read specifically for the question on if there's a legend on what's what. In this case, I'm going to say green is going to be positive. So here I have 2x squareds, right? Because these are squares. Then I want to minus x. So white is going to be negative. Minus x. And then it says 2 plus 5. So then I must add 5 of these colored ones here. And there we go. So it'll look something like that. So altogether, this here would be 2 of these, 1 stick, and 5 singles.